I'm Sukhmeen, and today we have with us Siddharth. He'll walk you through paper 12 of Further Maths, October November 2024. He'll go through each question in detail so that you can answer, so that you can perform well in your exams and understand the concepts better. Over to you, Siddharth.
Yeah, okay, so I'm Siddharth Reddy. I'll be solving for the Maths October November 2024 paper 1 2. So let's start. The sequence U1, U2, U3 is such that U1 is equal to 4 and UN plus 1 is equal to 3 UN minus 2 for n is greater than or equal to 1. Prove by induction that the term UN is equal to 3n plus 1 for all positive integers n. So this is a regular proof by induction. So the first thing you have to do is write base case, which is over here. Since we're saying positive integers, the smallest positive integer is n is equal to 1. Okay, so for the base case u1, we have 3 to the power 1 plus 1 is equal to 4, which is what is given in the question. So it's true for n is equal to 1. Next, you have to write like this. So assume that un is equal to 3n plus 1 for n is equal to k. So what we'll get then is uk is equal to 3 to the power k plus 1. And the final step is we have to write. So now let's just check for n is equal to k plus 1. So for n is equal to k plus 1, so you want to look at this part. So uk plus 1 is equal to 3 uk minus 2. So in the previous part, we already found out what is uk, so we can substitute that here. So 3 into 3 to the k plus 1 minus 2. So 3 times 3 to the power k is 3 to the power k plus 1. So then 3 into 1 is plus 3 and minus 2. So we have 3 to the power k plus 1. So 3 minus 2, that's 1. So this is the same thing which we get if we directly substitute k plus 1 in this formula. So the formula holds true for n is equal to 1 for k and for k plus 1. Hence, by the principle of mathematical induction, not BMI, by the principle of mathematical induction, the formula holds true for all positive integers. So yeah, this is how you solve like these proof by induction questions. So you have to write the base case, assume, and now check. Okay, next question. So the line L1 has equation R is equal to 1 plus 3j minus k plus lambda. So we can write this like this. So L1 does R is equal to 1, 3 minus 1 plus lambda 1 minus 1 minus 4. So the plane capital Pi contains L1 and is parallel to the vector 2, 5 minus 4. So it's the vector 2, 5 minus 4. So find the equation of this plane, giving your answer in the form ax plus by plus cz is equal to d. Okay, so what they're saying is there's a plane, something like this, and the line L, it contains L1, means L1 is passing through it like this. And there's also another vector which it is parallel to. So it's parallel to this vector. Okay, so in order to find the Cartesian equation of a plane, actually what we need to do is find the normal vector which lies on the plane. So means it's perpendicular to the surface of the plane. So we need two direction vectors which lie on the plane for that. So we already have one, which is 1 minus 1, 4. So 1 minus 1, minus 4. And there's another one because they said it's parallel to 2, 5 minus 4. So 2, 5 minus 4. So in order to find this perpendicular vector, we can do the cross product. So I, j, k. So we can put anything first. So 2, 5, minus 4, and 1, minus 1, minus 4. So taking the cross product, if you have this kind of calculator, you can directly put it in the calculator, but I'll still do the working. So we have cross out I, and you're left with this box. So you have to take the determinant of this 2 by 2 matrix. So that's 5 times minus 4 minus 4 times minus 1. So this I, and then minus. So same thing you do for J. So you're left with 2, 1, minus 4, minus 4. So 2 into minus 4 is, okay, I'll just write it first. 2 into minus 4 minus 1 into minus 4, J. And for K, same thing. So that's 2 into minus 1 minus 5 into 1. So that's minus 24 I. And 2 into minus 4 minus 8. Minus 8 plus 4, that's minus 4. But there's also minus, so it becomes plus 4. And 2 into minus 1 minus 5. So that will be minus 2 minus 7 K hat. Okay, we don't need to write the IJK, just erase that. So now that we have a normal vector, a perpendicular vector, what we need is any point on the plane. So for example, they gave this line which passes through. So this line contains the point 1, 3, minus 1. So we can use that as our point. Okay, I'm erasing this. We'll just call it D, and n times. So we're taking the dot product. Okay. So this will be minus 24, 4, minus 7 times D, which is the point 1, 3, minus 1, is equal to minus 24, 4, minus 7 times, this should be X, Y, Z. So this is equal to minus 24X plus 4Y minus 7Z. So minus 24 plus 12, that's minus 12. Minus 12 plus 7, that's minus 5. So we have minus 5 is equal to minus 24X plus 4Y minus 7Z. So just reorganizing and multiplying by minus, we get 24Y at 24X. 24X minus 4Y plus 7Z is equal to 5. Yeah. That's the solution for this question. The line L2 is parallel to the vector 5, minus 1, minus 2. Find the acute angle between L2 and the plane pi. So the plane is there. And there's another vector L2 just passing through it like this maybe. And they're asking us to find out this angle between the vector, the line and the plane. So we actually have to first find the angle between the line and the perpendicular, and then like do 90 minus that to find the angle between the line and the plane. So what is the line, the vector of the perpendicular? It was minus 24, 4, minus 7. So we have minus 24, 4, and minus 7. And they gave that the direction vector of this line is 5, minus 5, minus 2. Okay. So in order to find the angle, what we can do is take the dot product again. So 5 minus 5 minus 2. And instead of now multiplying the corresponding elements, what we can do is multiply the magnitudes. So like this 24 square plus 4 square plus 7 square into 5 square plus 5 square plus 2 square into cos theta, where theta is the angle between them. So now we can multiply this part on the left hand side. So minus 24 times 5, that's minus 120. So minus 120 minus 20 plus 14 is equal to square root of 24 square plus 4 square plus 7 square. 641 into square root of 5 square plus 5 square plus 2 square. It's 3 root 6 into cos theta. So cos theta is equal to this minus 140 plus 14. Okay, minus 126. Minus 126 by root 641 into 3 root 6. And theta is equal to the cos inverse of this thing. So when you put this in the calculator, we get 47.37. Actually, I got 132.62, but if you minus that, do 180 minus that, you get 47.37. So this angle is 47.37, but we need to find the angle between the line and the plane. So we need to take 90 minus that again. So 90 minus 47.37, we get theta is equal to 42.62. Yeah. It is given that alpha plus beta plus gamma plus delta, I'll call it ABCD, is equal to 2, and a square plus b square plus c square plus d square is equal to 3. And similarly, the sum of cubes is equal to 4. Find this sum. Okay. So this is the sum of roots taken 2 at a time. So for this, what you need to know is this identity. So like, for example, when you have a plus b whole square, you write that as a square plus b square plus 2ab. Similarly, when you have a plus b plus c whole square, write a square plus b square plus c square plus 2 into ab plus bc plus ac. So actually, what's always the multiples will be coming over here. So similarly over here, you have alpha plus beta plus gamma plus delta square. So that's equal to alpha square plus beta square plus gamma square plus delta square plus 2 times this sum of roots taken 2 at a time. I'm writing it in shorthand. So now we can just substitute these values. So we know this is 2. So 2 square is equal to 3 plus 2 root 2 sum alpha beta. So this 4 is equal to 3 plus 2 sum alpha beta. So 1 is equal to 2 root alpha beta. And the root sum of roots taken 2 at a time is equal to 1 by 2. Okay. So this looks pretty big, but it's not that big. So let's solve it. So first thing you want to note is always this, we can factor this as alpha square into beta plus gamma plus delta. We can factor this as beta square into alpha plus gamma plus delta. We can factor this with gamma square into alpha plus beta plus delta. And we can factor this as delta square into alpha plus beta plus gamma. Okay, let's go back the slide and write down this identity. So we have alpha plus beta plus gamma plus delta is equal to 2 always. So for example, if we want this, we can write beta plus gamma plus delta is equal to 2 minus alpha. And similarly, if we want this alpha plus gamma plus delta, we can write 2 minus beta. Okay, you should get the idea. So alpha square into 2 minus alpha plus beta squared into 2 minus beta plus gamma squared into 2 minus gamma plus delta square into 2 minus delta. Okay. And just expanding these brackets, we get 2 alpha square minus alpha cube plus 2 beta square minus beta cube plus 2 gamma squared minus gamma cube plus 2 delta squared minus delta cube. And again, further factorizing. So you have 2 into alpha squared plus beta squared plus gamma squared plus delta squared minus 2 into, so just minus alpha cube plus beta cube plus gamma cube plus delta cube. Okay, so if we go back, we can just check these values. So the sum of the squares, this was 3, so that's 2 into 3 minus, and the sum of the cubes was 3. Sum of cubes was 4. So 6 minus 4 should be 2. So this is the answer. It is given that alpha, beta, gamma, delta are the roots of the equation 6x to the power 4 minus 12x cubed plus 3x squared plus 2x plus 6 is equal to 0. Find the value of the sum of the powers to 4. So we can do this thing. So since each of these are the roots of this equation, it is perfectly valid to substitute it like this. So 6 alpha to the power 4 minus 12 alpha to the power cube plus 3 alpha squared plus 2 alpha plus 6 is equal to 0. And we can substitute beta also. So 6 beta 4 minus 12 beta cube plus 3 beta squared plus 2 beta plus 6 is equal to 0. And similarly, gamma. And substituting delta also. Okay. So now that we have these 4 equations, what we can do is actually take the sum. So taking the sum, we get 6 alpha to the power 4 plus 6 beta to the power 4 plus 6 gamma to the power 4 plus 6 delta to the power 4. So factoring out the 6, and we get like alpha to the power 4 plus beta to the power 4, so on. I'll be writing it shorthand as sum of the 4th powers. And similarly, we can write this as sum of the 3rd powers plus 3 times the sum of the 2nd powers squares plus 12 times the sum of the roots itself. And now plus 6 plus 6 plus 6 plus 6, that's plus 24. That's equal to 0. If we go back and check, they already gave us these values. So we have 6, this thing which we are trying to find, minus 12 into 4 plus 3 into the sum of squares, which is 3, plus 12 into the sum of the roots themselves, which is 2, plus 24 is equal to 0. So when we get that and solve for this, so we have, I'll note it x for now, 6 to the 6 times x minus 12 times 4 plus 3 times 3. I'll just put that in my calculator. Minus 12 times 4 plus 3 times 3 plus 12 times 2 plus 24 minus 48 plus 9 plus 4 plus 24 is equal to 0. So that's minus 11. So 6x minus 11 is equal to 0. So x is equal to 11 by 6. Yeah, actually this part is supposed to be 2, not 12. So yeah, so it's 2 times 2, which is 4, not 24. So like that, we get x is equal to 11 by 6. So the sum of the roots taken to the power 4 is equal to 11 by 6. This is the final answer. Find the value of the sums to the power 5. Okay, so this is the equation we have, 6x to the power 4 minus 12x cube plus 3x square plus 2x plus 6 is equal to 0. So we can actually multiply this by x throughout. So we get 6x to the power 5 minus 12x to the power 4 plus 3x cubed plus 2x squared plus 6x is equal to 0. Yeah. So we can do the same thing which we did previously and take the sums again. So we get 6 times sum to the power, sum of the fifth powers, minus 12 times the sum of the fourth powers, plus 3 times the sum of the cubes, plus 2 times the sum of the squares, plus 6 times the sum of the roots themselves is equal to 0. And we can now substitute the values. So we have 6, okay, I'll denote this x, 6x minus 12 into, so we found this out previously to be 11 by 6. So plus 3 into, this is 4, plus 2 into 3, plus 6 into 2 is equal to 0. So 6x is equal to, okay, if we just solve this part, okay, 6x, so minus 12 into 11 by 6, plus 3 into 4, plus 2 into 3, plus 6 into 2. So this is 8. Yeah, 6x plus 8 is equal to 0. So 6x is equal to minus 8 and x is equal to minus 8 by 6 is equal to minus 4 by 3. So the sum of roots to the fifth power is equal to minus 4 by 3. Yeah. Okay. Let's go to the next question. The matrices A, B, and C are given by A is equal to this one, B is equal to this, and C is equal to this. Show that CAB is equal to 3 minus 7 minus 9, 3. So this is a matrix multiplication question. So in these type of questions, you have to know that the matrix multiplication moves from right to left. So first we have to multiply AB, and then we have to multiply that product with C. So first let's find out AB. So AB is equal to 1, 2, 3, 2, 1, 3, 3, 2, 5 times 0 minus 2, minus 1, 3, and 0, 0. Okay, so the process is actually pretty arduous. So I recommend you guys to get some calculator which has the matrix multiplication enabled. So I'll still be doing it for you guys. So the result will also be a 2 by 3 matrix. So the method of multiplication is first, when you want to find out the top left, you have to take the corresponding row, and take the corresponding column and multiply the elements. So 1 times 0 plus 2 times minus 1 plus 3 times 0. So that's 2 times, that's minus 2. Similarly, for the top right, for this top right one, you have to take the corresponding row and the corresponding column. So that's 1 times minus 2 plus 2 times 3 plus 3 times 0. So 1 times minus 2, that's minus 2 plus 6, that's 4. And same thing for the middle row also. So 2 times 0 plus 1 times minus 1 plus 3. So that's minus 1. And okay, I won't be drawing the lines anymore, but 2 times minus 2, that's minus 4, plus 1 times 3, that's minus 1, plus 3 times 0, so it's still minus 1. And finally, you have 3 times 0 plus 2 times minus 1, which is minus 2, plus 5 times 0. And you have 3 times minus 2, which is minus 6, plus 2 times 3, which is 6. So that's, it stays 0. So it's minus 2, 4, minus 1, and minus 2, 0. So this is AB. And now we have to multiply it by C also, which C is minus 2, minus 1, 1, 1, 1, 3. Okay, I'll erase this side. Yeah. So same thing. So now this is going to be a 2 by 2 matrix. So it's going to be only these. You can try to like visualize it by overlapping it on each other. So it's only two columns, only the 2 by 2 matrix will match. So same thing, we take the row and multiply it by the corresponding column, like this. And this will be minus 2 times minus 1, minus 2 times minus 2, which is 4. Okay, so this part will be minus 2 times minus 2 plus minus 1 times minus 1 plus 1 times minus 2. So 4 plus 1 minus 2, which is 3. Okay. The top right column, same thing, like this. So you have minus 2 times 4, minus 1 times minus 1, plus 1 times 0. So that's minus 8 plus 1. So that's minus 7. And now 1, 1, 3, and minus 2, minus 1, minus 2. That's 1 times minus 2, which is minus 2, minus 1, minus 6, which is minus 9. And finally, we have this one. So 1, 1, 3, and 4, minus 1, 0. So that's 1 times 4, which is 4, 1 times minus 1, which is minus 1, and 3 times 0, which is 0. So this is just 3. So what we got. And yeah, it's the same thing, show that. So again, this process is really long, so I recommend you guys to get like a calculator so you can do it quickly and confirm your answer also. So find the equations of the invariant lines through the origin of the transformation in xy plane represented by CAB. So invariant lines are actually the lines which are not affected by the geometric transformation done by matrices. So you should know that each matrix represents like a geometrical transformation on the 2D plane. Okay, so you have 3 minus 7 minus 9 and 3. So this is the method to find invariant lines. So first we have matrix times vector multiplication. So it will be 3x minus 7y minus 9x plus 3y is equal to x, y. So invariant lines which pass through the origin, for example, like this. So all straight lines can be modeled using y is equal to mx plus c. And since it passes through the origin, c is equal to 0. So just y is equal to mx. So we can substitute it over here. So 3x minus 7mx is equal to capital X. And minus 9x plus 3mx is equal to m capital X. So we have this for x and we can substitute it. So we have minus 9x plus 3mx is equal to m into 3x minus 7mx. So cancel all the x's. So that's minus 9 plus 3m is equal to 3m minus 7m square. 3m cancel. So you have 7m square is equal to 9 and m square is equal to 9 by 7. So let me create some space. So m square is equal to 9 by 7 and m is equal to plus minus 3 by root 7. So substituting back into y is equal to mx, we can get y is equal to 3 by root 7 x or y is equal to minus 3 by root 7 x. Yeah. Let m is equal to this matrix 3001. Give the full details of the transformation represented by m. So as I said before, each matrix represents like a geometric transformation on the 2D plane. So on the 2D plane, there'll always be two components, I hat and j hat. I hat is the vector 1, 0, and j hat is the vector 0, 1. So actually what the first column of the matrix represents is where the vector I hat goes. So in this case, it's 3, 0, which means it will be stretched out like this. So any corresponding vector on the plane will also get stretched out like this. So this transformation is a stretch along the x-axis by scale factor 3. Okay, find the matrix N such that M is equal to CAB. So we have M is equal to 3001 from the previous question, and CAB is equal to 3 minus 7 minus 93. Okay, so CAB 3 minus 7 minus 93. Yeah. So they're asking for a matrix N. For example, let's model this using A, B, C, D. So when you multiply this with M, you get CAB. So A, B, C, D times 3001 is equal to 3 minus 7 minus 9, 3. So we can do this like this. So we can do the regular matrix multiplication. So, and then match the variables. So this top left column will be a times 3 plus b times 0, which is 3a. Top right will be a times 0 plus b times 1, which is b. Bottom left will be c times 3 plus d times 0. Yeah, so it is 3c. And bottom right will be c times 0 plus d times 1, which is d. So this is equal to 3 minus 7 minus 9, 3. So 3a is equal to 3, which means a is equal to 1. B is equal to minus 7. C is equal to minus 3. And D is equal to 3. So the matrix N is equal to 1, 7, minus 3, 3. Or actually it's minus 7. Yeah, minus 7. 1 minus 7 minus 3, 3. Okay. It is given that Sn is equal to the sum from R is equal to 1 to N of U sub R, where U sub R is equal to x to the power f of R minus x to the power f of R plus 1. Find Sn in terms of n, x, and the function f. Okay. So this question looks complicated, but it's not that difficult. So what they're saying is that there's a summation which is equal to R is equal to 1 to N of U sub R. So U sub R, they gave us x to the power f of R minus x to the power f of R plus 1. Okay, so the sum from 1 to n. So they're asking us to find this. So it means first we substitute R. So x to the power f of 1 minus x to the power f of 2 plus x to the power, substitute 2 now, f of 2 minus x to the power f of 3 plus, now when we substitute R as 3, x to the power f of 3 minus x to the power f of 4, and so on, until you get x to the power f of n minus x to the power f of n plus 1. So just note this thing. So this minus x to the power f of 2 and plus x to the power f of 2 will cancel. Similarly, this minus x to the power f of 3 plus x to the power f of 3 will cancel. So it keeps on cancelling like that until we are left with x to the power f of 1 minus x to the power f of n plus 1. That's the answer. Given that f of r is equal to ln r, Find the set of values of x for which the infinite series is convergent and give the sum to infinity when this exists. Okay, so f of r is equal to ln of r, which means that I accidentally closed the slides. Yeah. Okay.
Are there any common mistakes that people make when answering these questions?
No, it's
Or like,
mostly like silly mistakes. Like
sorry?
it's mostly like silly mistakes, like a lot of tedious calculations.
Like what kind of silly mistakes, like plus minus, or like do they
Yeah,
forget?
it's mostly plus minus.
Okay.
Given that f of r is equal to ln of r, find the set of values of x for which the infinite series u1 plus u2 plus u3 is convergent and give the sum to infinity when this exists. Okay. So they gave ur is equal to x to the power f of r minus x to the power f r plus 1. So since they gave f of r is equal to ln r, we can write this as such. X to the power ln r minus x to the power ln r plus 1. So what they're asking here is the sum from r is equal to 1 to infinity of ur, which we already found uh, to be equal to x to the power f of 1 minus x to the power f of n plus 1. So substituting f of x is equal to ln x. So we get x to the power ln 1 minus x to the power ln n plus 1. So anything ln 1 is always equal to 0, and anything to the power 0 is 1. So we get 1 minus x to the power ln of n plus 1. So now they're asking, when is this series convergent? Give the values of x for which this infinite series converges. So convergent means it approaches like a specific value. So we should note that this happens only when x is in between 0 and 1. Because if it were greater than 1 or less than 1 also, then since n is tending towards infinity and you take the power of that, the x to the power of that also becomes greater and greater and approaches infinity instead of a specific value. So that's the first thing. Secondly, they said x is always greater than 0. So we have to cut out this equal sign. So it's always going to be like this. So, and give the sum to infinity when this exists. So when x is equal to, when x is equal to 1, then it becomes 1 minus 1 to the power infinity, which is just 0. So when x is equal to 1, sum is equal to 0. And when x is less than 1, it becomes like this. So 1 minus x to the power infinity, but suppose something like a 0.5. So 0.5 to the power infinity, when it tends, any number between 0 and 1, when you raise it to the power infinity, it becomes 0. So it becomes when x is less than 1, the sum is equal to 1 because it's 1 minus 0. So that's the answer for this question. Given instead that f of r is equal to 2 log r base x, where x is not equal to 1, use standard results from the list of formulae MF19 to find this sum, the sum of Sn, so the sum of a sum in terms of n. Fully factorize your answer. Okay, so first let's find out Sn. So Sn, we already found out that it's x to the power f of 1 minus x to the power f to the power minus x to the power f of n plus 1. So now they give f of r is equal to 2 log base x of r. So we can write this as log base x of r square. So we can write this as x to the power log base x r square minus x to the power log base x of 1 square of n plus 1 square. So this x log x cancels and we are left with uh, yeah 1 minus, and again this x log x cancels and we're left with n plus 1 whole square. Okay, so this is 1 minus n square plus 2n plus 1. So this becomes minus n square. This 1 and minus 1 cancels. So minus n square minus 2n. So this is what Sn is equal to. But they're again asking what is the sum of Sn from n is equal to 1 to n. So you have to take sum from r is equal to 1 to n of minus n square minus 2n. Okay, so this is going to be equal to minus the sum of n square minus 2 the sum of n. And if you check the formula MF19, so they give the value of the sum of squares. It's equal to n into n plus 1 into 2n plus 1 by 6. So this will be equal to minus n into n plus 1 into 2n plus 1 by 6. And the sum of the regular n is equal to n into n plus 1 by 2. It becomes 2 into n plus 1 by 2. So this 2 cancels. So we're left with, let me erase some things. So we have here minus n into n plus 1 into 2n plus 1 by 6 minus n into n plus 1. So we can multiply the numerator and denominator by 6. And finally what we get is, and we can also factor out the n and n plus 1. So minus n into n plus 1 into 2n plus 1 plus 6 by 6. So this becomes minus n into n plus 1 into 2n plus 7 by 6. Yeah, let me just write that a little neatly. Okay, so the next question, question 6, the curve C has equation y is equal to x squared plus 3 divided by x squared plus 1. Show that C has no vertical asymptotes and state the equation of the horizontal asymptote. So vertical asymptote happens when the denominator is equal to 0. So x squared plus 1 is equal to 0. This equation x squared is equal to minus 1 actually only has imaginary roots. So it has no real solutions. And the equation of the horizontal asymptote. Horizontal asymptotes occur when the degree of the numerator and denominator are equal. So in both the numerator we have x square and denominator also. So if you want to find the horizontal asymptote, you have to divide the coefficients. So in this case it's 1 and 1 only. So the horizontal asymptote will be y is equal to 1. Show that y is between 1 and 3 for all real values of x. Okay. So we have y is equal to x square plus 3 by x square plus 1. So we can write this as x square plus 1 into y is equal to x square plus 3. So x square y plus y is equal to x square plus 3. And x square y minus x square plus y minus 3 is equal to 0. Factoring out x square, we have x square into y minus 1 plus y minus 3 is equal to 0. So they're saying for all real values of x, that implies that there are there are no intersections with that. Like there are full, um, the equation has all solutions. Wait, can we cut that part out?
You can say it again if you want. If you want to.
Okay, so is it that show that for all real values of x, so that means x has no imaginary solutions. So that means that the b square minus 4ac of this equation, the discriminant, is always greater than or equal to 0. So b, there's no x term with a degree of 1. So this b is 0. So that's 0 square minus 4 into coefficient over here is y minus 1. And c is y minus 0. So this is greater than or equal to 0. So 0 we can just erase. And dividing by minus 4, we get y minus 1 into y minus 3 is less than or equal to 0. When we divide by a negative sign, the inequality gets flipped. Okay, so now we have this quadratic equation. Y minus 1 into y minus 3 is less than or equal to 0. Just expanding, we get y square minus 3y minus y plus 3 is less than or equal to 0. Y square minus 4y plus 3 is less than or equal to 0. So we just draw this quickly. We get something like this, where the solutions are 1 and 3. So they're saying when is it below 0? So it's below 0 when it's below this axis. And you can see that it's only below the axis between 1 and 3. So y has to be between 1 and 3. But it's not done just yet, because if you notice in the question, they didn't give this extra inequality sign. So that's because at y is equal to 1, at y is equal to 1, we have 1 is equal to x square plus 3 by x square plus 1. This equation has no solutions, because it becomes x square plus 1 is equal to x square plus 3. Cancelling of the x square, we get 1 is equal to 3. It is obviously not possible. So y cannot equal to 1. So it's only 1, y is greater than 1 or less than or equal to 3. Find the coordinates of any stationary points on C. So stationary points occur when the dy by dx is equal to 0. So we're not find the dy by dx of this. So let's just bring. So y is equal to x square plus 3 by x square plus 1. Yeah. So dy by dx is equal to, so you should know the quotient rule, like how to derivate fractional functions. So x square plus 1 into derivative of numerator, which is 2x, minus x square plus 3 into derivative of the denominator, which is again 2x, by the denominator square, which is x square plus 1 whole square. And this is equal to 0. So since it's equal to 0, we can just multiply this denominator out. So it becomes x square plus 1 into 2x minus x square plus 3 into 2x is equal to 0. So factoring out the 2x, yeah, get x square plus 1 plus minus x square plus 3 is equal to 0. So 2x into x square minus x square and 1 plus 3. That's, hold on. Yeah. So the only solution for this is x is equal to 0. So at x is equal to 0, y is equal to 0 square plus 3 by 0 square plus 1, which is 3. So the only stationary point is 0, comma 3. Okay. Sketch C, stating the coordinates of any intersection with the axis and labeling the asymptote. Okay. So let's put everything together. So they gave one, we found out one asymptote, which is y is equal to 1. So we can draw that with a dotted line. So this y is equal to 1. And we found one stationary point also, which is 0, comma 3. So it's somewhere over here. So by the way, it's also an intersection of the axis. We can note that over here, 0, comma 3. So this function would look something like this. Yeah. So it never crosses the asymptote. Okay, sketch the curve with equation y is equal to x square plus 1 by x square plus 3. So this is actually the reverse. So the function they gave initially was x square plus 3 by x square plus 1. This is x square plus 1 by x square of 3, x square plus 3. So it's a 1 by f of x, it's the reciprocal. So we have to draw this one also. So before the stationary point was 0, comma 3, now it's going to be 0, comma 1 by 3 because we are taking the inverse. And before this, the asymptote was y is equal to 1. Still now also it will be y is equal to 1 also because 1 over 1 is just 1. So same thing. So y is equal to 1. So now it just passes through here. And it's almost like a upside down flip. Yeah, okay. You should probably draw it more symmetrical in the exam, but yeah. And to find the set of values for which x square plus 1 by x square plus 3 is less than 1 by 2. Okay. So what they mean is that there's some point, there's this line 1 by 2, for which values of x is it between this? Is it below this 1 by 2, this part? So that's not very difficult to find out. We can just do it like so. Okay, so first let's find out the intersection points. So x square plus 1 by x square plus 3 is equal to 1 by 2. So we get 2 into x square plus 1 is equal to x square plus 3. So 2x square plus 2 is equal to x square plus 3. And we get x square is equal to 1. So x is equal to plus minus 1. So this point will be minus 1 and this point will be plus 1. So the set of values for x for which it is below 1 by 2 will be x is greater than minus 1 and less than plus 1.
Also, do you label the graph, the axis in these questions?
Yeah,
And
yeah,
yeah,
it's not.
okay.
Yeah, and we can also label the graphs with y and x. Okay, so this is the final question. Okay, so this is the seventh question. The curve C1 has polar equation r is equal to a into cos theta plus sine theta for minus pi by 4 and 3 pi by 4, where a is a positive constant. Find a Cartesian equation for C1 and show that it represents a circle, stating its radius and the Cartesian coordinates of its circle, of its center. So these are the three things you should remember. R square is equal to a square plus x square plus y square. x is equal to r cos theta and y is equal to r sine theta. So here cos theta we can write as x by r, and sine theta we can write as y by r. So substituting that into this, so r is equal to a into x by r plus y by r. So r is equal to a by r into x plus y. R square is equal to a into x plus y. And substituting this one also, we have x square plus y square is equal to ax plus ay. Bringing them all to one side, we have x square minus ax plus y square minus ay is equal to 0. And we can just complete the square here. So we have x square minus ax plus a square by 4 minus a square by 4 plus y square minus ay plus a square by 4 minus a square by 4 is equal to 0. So you can write this as x minus a by 2 whole square minus a square by 4 plus y minus a by 2 whole square minus a square by 4 is equal to 0. And if we bring a square by 4 to both of the a square by 4 to the other side, we get a square by 2. So this will become x minus a by 2 whole square plus y minus a by 2 whole square is equal to a square by 2. So these represent the coordinates of the center. So the center will be on a by 2 comma a by 2, and the radius is the square root of this one. So that's a by root 2. Okay. Sketch C1 and state the greatest distance of a point on C1 from the pole. So this is the polar coordinate graph. So we got that the center is a by 2 comma a by 2. So something over here. So a by 2, a by 2. And the radius is a by root 2. So actually we just check using Pythagoras theorem. So this length will also be a by root 2. So this circle passes through the origin. So it looks something like this. So this is the radius. So that's a by root 2. So obviously the furthest point from this origin will be the opposite. So it will be another a by root 2. So it's 2 times a by root 2, which is 2a by root 2. 2 by root 2 cancels, so it gets root 2a. So this is the distance. Okay, the curve C2 with polar equation R is equal to a theta intersects C1 at the pole and at the point with polar coordinates a phi, comma phi. Verify that 1.25 is this angle is between 1.25 and 1.26. So just drawing that again. So there is another graph a theta. So it looks something like this. So it will spiral out like this. So we don't need to draw that much. Only we need to draw the part which intersects with the circle. So this is one intersection point. And of course, this one more intersection point at the pole. So let's find out the coordinates of this intersection point. So the polar equation was r is equal to a cos theta plus sin theta. So r is equal to a cos theta plus sin theta. This is for the circle. And for this extra spiral graph, the equation was r is equal to a theta. So if we want to find the intersection, we have to equate these. So a theta is equal to a into cos theta plus sin theta. So that's a gets cancelled. Theta is equal to cos theta plus sin theta. and 0 is equal to cos theta plus sine theta minus theta. Okay, so verify that this thing, the solution lies between 1.25 and 1.26. So the method of doing that is actually substituting 1.25 and then substituting 1.26 and show that there is a sign change. I'll show you how. So cos of 1.25 plus sine of 1.25 minus 1.25. So make sure your calculator is in radians mode. So cos of 1.25 so this is equal to 0.014, and if we take cos of 1.26 plus sine of 1.26 minus 1.26, we get minus 0.02002. So we can see between these two inputs, we actually got a sign change. It went from positive to negative. So what that actually means is that there is a root between 1.25 and 1.26 at which the result will be exactly 0. Yeah. So that's how you solve this question. You have to write down this working in the exam. You have to show that the sign change, there's a visible sign change. Then only you get the mark. Show that the area of the smaller region enclosed by C1 and C2 is equal to a square by 2. Okay, show that it's equal to this. And deduce in terms of a and phi the area of the larger region enclosed by C1 and C2. Okay, so just drawing this on the side. So what they're talking about is that there is this area and there is one more large area, this one. So they're asking us to find out first the area of this small part, and then deduce the area of the large part. Okay. So this is going to be a long question. It's a big integration question. So first what we need to do is, again, drawing it in big, so I'll explain what is the process. So first we need to find out this area and then add this area. This is the area enclosed between the line of intersection and the a theta, the spiral curve, and this one is the area enclosed by the line and the circle. So we can write it like this. So it's equal to area from 0 to phi of the circle, of the spiral. So that's a theta. So when we're taking the polar coordinate integral, we have to multiply by half and square it. So d theta plus integral from phi to this angle. If we go back, they actually gave it as 3 pi by 4. Okay, so this 3 pi by 4 of what is the equation of the circle? It's 1 by 2 into a into cos theta plus sine theta whole square. Okay, I'll be erasing the diagram. So this is equal to 1 by 2 into integral of from 0 to phi of a square theta square d theta plus half of integral from phi to 3 pi by 4 of a square into cos square theta plus sine square theta plus 2 cos theta sine theta d theta. So we can, a square is a constant, so we can bring it outside. So we get a square by 2 into this integral from 0 to phi of theta square d theta plus a square by 2 into the integral from 5 to 3 pi by 4. So cos square plus sine square theta is just 1. So 1 plus 2 cos theta sine theta. And this 2 cos theta sine theta also we can write as sine 2 theta. So it's given in the formula sheet like that. Yeah. So now we just evaluate the integral. So this is going to be equal to a square by 2 into theta cube by 3 from 0 to 5 plus a square by 2 into, so integral of 1 is 1 d theta is just going to be theta, and integral of sine 2 theta. So what integral means, like the antiderivative. So when we derive a certain function, we should get sine 2 theta. So for example, if we derive cos 2 theta, we get minus sine 2 theta times 2. So now in this question, there's no minus sign. So in order to like counteract it, we have to add a minus sign here. And there's no times 2 also. So you have to divide by 2. So the antiderivative of sine 2 theta will be minus cos 2 theta by 2. And this is going from 5 to 3 pi by 4. Okay. So we can evaluate this like this. So substituting 5, we get 5 cube by 3 minus 0 cube by 3 is just going to be 0. Okay, so we don't need that. And plus a square by 2 into substituting 3 pi by 4 for theta minus cos into 2 cos into 2 into 3 pi by 4, that's 3 pi by 2 by 2 minus 5 minus cos of 2 phi by 2. Okay, so this becomes a square by 2 into 5 cube by 3 plus a square by 2 into 3 pi by 4 minus cos of 3 pi by 2. So let me just put that in the calculator. So this is just 0. So it's just 3 pi by 4 minus 5 plus cos of 2 phi by 2. And again, we can factor out a square by 2 over here and here. So this becomes a square by 2 into 5 cube by 3 plus 3 pi by 4 minus 5 plus cos 2 phi by 2, which is the same thing which is given in the question. So we got this part. And deduce in terms of a and phi the area of the larger region enclosed by C1 and C2. So let me erase this part. So we found out the area of the smaller. The area of the larger section will just be the area of full section, full circle, minus the area of the smaller section.
So in questions like these, I think patience would be the biggest thing you
Yeah,
should follow. And I also think like you should do the working like really clearly. Otherwise, you tend to make more errors. The silly
yeah.
errors. Yeah.
So the area of big section is equal to area of circle minus the area of small section. So this is the area of the small section. And we know the radius of the circle, it will just be pi r square. And we know that r is equal to a by root 2. So that's pi into a by root 2 square. So that's pi a square by 2. So this area of the big section will be pi a square by 2 minus this one. Minus a square by 2 into 5 cube by 3 plus 3 pi by 4 minus 5 plus cos 2 phi by 2. So we can write factor of the a square by 2 again. So a square by 2 into pi plus 3 pi by 4 plus 5 cube by 3 minus 5 plus cos 2 theta by 2. So this is equal to, so pi plus 3 pi by 4. So yeah, actually this should be pi minus this because it's pi into a square minus this. So factoring we have to add the minus sign. So it becomes a square by 2 into pi minus 3 pi by 4. That's just pi by 4 minus 5 cube by 3 plus 5 minus cos 2 phi by 2. So that should be the answer. So minus 5 cube by 3 plus, yeah. So that's the answer. So that's the end of the paper. So thank you guys for watching so much. If you want more notes, make sure to sign up on ZNotes and subscribe for more helpful video content. Please follow our socials.
Thank you so much, Siddharth, for the wonderful explanation. Everything felt much clearer after you explained it. I hope everyone found it useful. See you in our next video where Siddharth will be solving another one of paper ones. Okay, thank you, everyone.